Hey there, I'm Sam, and I'm going to be doing another tech interview question. We'll be choosing an easy one in the algorithm space, and the goal of this is for me to act like a tech interview candidate. Um, with an easy question, you're in a more of the entry level L3, L4 range for a tech company. And I think even though you can do medium questions, being able to really knock out easy questions is important. And more importantly, I'm quite rusty, so this is probably just appropriate for me. So let's pick one at random, and I'll start the timer. All right, so what do we got here today? 1935, maximum number of words you can type. There is a malfunctioning keyboard where some letter keys do not work. All other keys on the keyboard work properly. Given a string text of words separated by a single space, no leading or trailing spaces, and a string broken letters of all distinct letter keys that are broken, return the number of words in text you can fully type using this keyboard. So for example, if the text is hello world and the broken letters are A and D, return the number of words inside of text you could type using this keyboard. So we could not type the word world. That's a tongue twister because the D key is broken. Okay, this is starting to make sense. And the output's 1 because it can write hello. Similarly, Leetcode with L and T, you couldn't do Leet, but you could do code, so it's 1. And then finally, Leetcode, but E is gone. Both code and Leet have it, so 0. Some of the questions I'd have is, are we just doing lowercase alphabetical? Are there limits to the characters? Will we get valid inputs? Generally, the interviewer will start off with a yes and or this is where they can decide how to change the question up. For Leetcode, and in this case, it looks like our input text length is always going to be fit comfortably within memory, and the number of broken letters is going to be within 0 through 26. That was another question: is broken letters going to all be unique characters? Do we need to create a set of it? In this case, it looks like broken letters will always contain distinct lowercase English letters, so we don't need to pre-sort or pre-setify this to avoid extra work. Text contains only words separated by a single space without any leading or trailing spaces. Okay, so there's a few ways we can kind of approach this. This is a string manipulation type question. Python provides a lot of nice libraries for doing this already. We want to essentially tokenize this string, which is break it up into words, and Python makes it quite easy to do that. We could just do, text.split, and we can even pass in what the delimiter is in this case. And so then what would happen there is hello world would become hello and world, and this would now be a list. And I think I'm pretty sure the interviewer, first you have to ask the interviewer if it's all right, we can do this, because maybe they want us to actually tokenize a string ourselves, and that might be totally valid. But let's pretend we're allowed to use this right now. We have this list of strings, and tokenizing a string like this will end up being an O of n operation for the length of the string. Var of characters, or string length. And that's fine. I don't think we can ever do better than O of n because we have to check every character in this whole text. And then what I'd like to do is for every word inside of this list, we just check if the word contains a letter. And the way we could do that is by either iterating we can do set comparisons. So one option is we turn every word in this list into a set, and then check for each character whether that broken letter is inside of that set. And then where that becomes generating a set for each word would become, at the end of the day, set creation is O of 1. It's kind of like building a dictionary. O of n for the length of the word, and then for the whole text it would be O of n. So sets for each word becomes O of n overall. And then for each broken letter, check if letter is in word, in set word. Check if the letter is in, for each broken letter, for each word, check if letter is in word. So this is going to be O of, let's call this M, for M is number of broken letters. And then for each word, this is going to be O of K for length of word, number of words. And then check if letter is in word is O of 1. And here it's kind of hard to, K is a new one created where number of words K is going to be like basically N divided by the number K times C is equal to N, something along those lines. Let's not get too in the weeds for that right now. So if letter is in word, still good. I think if we switch the order of that, and then for each word, then for each letter, let's say we have a count. I'm just kind of creating a, for each broken letter, letter is in word. And what I'd like to do is kind of just check. And then we do like an all on that, basically. And if that's true, then we can append it into the count. Because that means every broken letter, if letter is not in word. Okay. And you guys should be able to still see this. So what I'm trying to do here, I'm just writing out this kind of pseudocode. For every word, if the letter is not inside of the word for each broken letter, and all of that is true, then that means this word is valid for, is typable. And we can increment the count. And then if it's not, we continue onwards. And so this becomes O of M for the number of broken letters. And for each word, we can just create word set. Something like that. And that way, doing a letter not in is O of 1. So it becomes O of M times 1. Because if we didn't do that, it would become O of M times the length of the word, the number of characters in the word. And this is still a O of C. And word, and O of K times C is equal to O of N essentially at that point. So that can kind of comes together because the number of words times the number of characters in each word is equal to the length of the string. So that ends up being O of N times M time, and space is O of C space for characters in a word max. And then at the very end, we return the count. So we can kind of pull this all together. Let's create a little, loop around here. So we're about, oops, sorry. There, is that timer still visible? There we go. 8 minutes and 35 seconds. This is a reasonable start. So we'll call this max typable. And we'll pass in the text, which is a string, and we pass out an int, which is the count. We're gonna tab all that. Count is initialized to 0. For each word, we need to create for each word in, let's turn this into actual code at this point. And let's bring this down in size so you guys can see it. For each word in text.split, and that's an O of N operation right there. And we're going to split it on space. for each word inside of that, make a set from that word, check for each letter, for each broken letter, and broken letter is going to be passed in also, and we're going to call that, I don't know, broken letters, it looks like, which is also a string for letter in broken letters. And this is kind of an inline for loop. So for letter in broken letters, we check if that letter is letter in word set, and we want the not of that. And I think we're allowed to do not that way. I'm not entirely sure. Can we do not in? If you're writing this with the interviewer, they can probably just say that's okay or not. We'll have to see what Leetcode has to say about this. So letter not in word set for letter in broken letters, all of that is true. Then we add to the count. And technically we can put this inside of here also, but because it's part of this for loop, let's keep it outside. Even though I think not the compiler, but the interpreter would figure that out. No need to make life hard for it. Okay. I think this makes sense. What are some edge cases we have? What happens edge cases? What if the text has only is empty? Are we allowed to have that? Text length is always going to be at least 1. Broken letters will be, okay, broken letters could be 0. If that's the case, we should actually have a quick check. If all, what happens when you do the all of an empty iterator? Is that returned as true? I think that might be the case, but let's see. Let's actually just make this its own thing. If not broken letters, because an empty string is considered not, return length of words. All are valid. Let's do it that way. That way we are guaranteed that once we get past this point, we have some broken letters, and this will iterate over that. If the text is empty, if not text, return 0. I think is a reasonable check also. If we have no text, no words, then there's no point doing anything beyond that. Even though technically the for loop would not start for words, because words on split off an empty string would still be an empty list, and we'd return a count of 0 at that point. But this just makes it extremely clear. So will this work, for example, for Leetcode? So words will become Leet and code. Text exists. Let's move that below. And then broken letters is E, so it exists. So for each word in words, we start with Leet. The word set will become L-E-N-T. It checks if L is in there, no. E is in there, yes. So this becomes false, and all will fail at that point. We could actually switch this around and turn this into an any, and that just simplifies it. If any of the broken letters are inside of here, then we can break out. And then do a not of that. And that actually is a little faster, I think, because that way it'll break immediately on the any rather than all, which has to check every single one. And it'll still end up checking everything, so it's not really faster, but it's just a little bit clearer visually for me to understand. I'm just checking if the broken letter's in the word, and if it's in the word and any of them's true, then we failed. And we do the not of that, so And that way we're allowed to increment the count. And then finally we return the count. All right, we're about 15 minutes in. I think we're close. And same applies to code, C-O-D-E. Will it work for the correct one? Hello world, hello H-E-L-O. And A and D are checked on that. They're not in it. A is not in it. D is not in it. So any is false and not of that is true. Counts +1. Okay, let's try it. And here we are. Okay, text and broken letters is the same. No tabs. Broken letters, word. I'm trying not to run straight away because I want to see if I can catch any errors ahead of time. And what we've kind of established here is that this should be a O of n times m time, O of S or C space, because we're only ever creating the largest set will be the number of characters in a word. M C Karen words. And they've also guaranteed or told us that a word is split by a single space. So it's always going to be a space. So this is valid. All right, let's do a test case. Oh, no. Invalid syntax for each. Oh, for word in words. This is one of the pitfalls of trying to convert your pseudocode into code directly. Okay, it passed for the test cases. Let's see, are there any other cases where it might break? We have a text length of 1. It's still a single word. Broken letters could be 0. We could do a check for that. Max of 26. All right, let's try submit it and see how it goes. And we are accepted. All right, that's always good to see when it is accepted on the first go. Don't worry about the times here. Again, for these kind of questions, especially with Python, you're going to be limited more by the backend that runs the system, and rather than the actual algorithmic cost, unless you're really inefficient. So, can be typo words. Cool. All right, this feels pretty good. I'm happy with what I've seen here. We could have kind of talked about some other approaches, and I didn't do that here. I just kind of went straight to this iterative approach. I didn't talk about what we could have done differently from this set right here. So what you could have done if you hadn't used the set is inside this loop, you could have done a check for letter in word, the list itself, and that would have become a O of C, M times C option here. So then this would have become a O of NMC time space complexity. So a bit worse, but then your space complexity has, well, technically we're creating a whole new list here. So this has become O of N space complexity here. And that is larger than O of C. So this is an argument for not using text-to-split. So we're at about 20 minutes in. We can now start talking about what happens if we want to reduce the space size. Oh, sorry about that. So instead of splitting up the words, we could just iterate through this string directly. So let's talk about approach 2. Because approach 1 is not space efficient, not as space efficient as it could be, because we've had to recreate space. Splitting string increased, uses end space. Because we created a whole new list inside of Word. So what can we do to avoid doing that? And the way I'd like to do that is by, instead of breaking up the word, what I'd like to do is iterate over characters in a word, iterate over characters in text. If we reach a space before a broken letter, increment have a valid word, increment the count. Otherwise, fail. Otherwise, skip till next space, or at end of string, return. That's basically the kind of iteration I'm trying to go for here. And this is actually really nice because we will be doing a checking for a broken letter still O of M, but we're doing O of NM times still, because for every character, which is O of N, so count equals 0 still. If it's empty, we keep that. And then for char in text, and what we can do now is the opposite. We can create a broken letter set equals the set of broken letters. And the reason I'm doing that is because instead of checking if the broken letter is in the character, we can just check if the character is inside of broken letters. And while we could just do it over the list of broken letters, which would be O of M, we can do it over the set of broken letters. And that's just a one-time O of M operation here outside of the loop. And this will be O of N within the loop. And then if char in broken set, let's start with a valid counter. Valid equals true. If char is in broken set, we are no longer valid. Now, else if the char is equal to empty space, if the char is in equal to empty space, and if valid, count plus 1, because we've had a valid word passed. Otherwise, and also we need to reset valid equals true again. A question I might have is whether we could have two spaces in a row or just an empty space as an input. And I think, oh, sorry, one sec. They said that text will consist of words separated by a space without any leading or trailing spaces. So we should never have a case where there'll be more than one space in the word. Otherwise, we'd have to do a special check for this. But the nice thing is we don't have to worry about this or word one, word, something like that. So we can assume that there will be at least a valid, the first character will be a actual character or an empty string, and it'll never be multiple empty strings in a row. So if the character is in the broken letter set, then its valid is set to false. This word fails. Otherwise, if the character is a space, then valid becomes true, and because we've started to the next word. And if valid was already true for the last one, then we increment that counter. Otherwise, it's a word. So we don't actually even have to do that because we're just going through those characters. And then finally, at the end of this all, we return count. And we need to do a check at the very end for the last character. Check. If valid is true, which can't be a space. Valid is true, count +1. Okay. Actually, this is quite clean and nice. I do like this approach a lot too. Let's have a go with it. I'm pretty sure. So the beauty of this one is we're doing an O of n operation here. We're doing an O of 1 check here. And we did O of n before. So our final time is O of n plus m, I believe. Is that right? Char in broken letter set. Yeah. So it's not even n times m, is it? So this is actually better. I wonder if we could have done that down here. Not exactly. Well, this is O of k. C, yeah, I see. All right. So I think this actually might end up being a more optimal solution. So I'm glad we started talking about this. Time and then space is O of m, because we're building a set of the broken letters. And actually, since broken letters can only be unique characters or string, but that's equivalent to O of 1 when we get it passed in, because it's unique letters, lowercase alphabet, can be 0 to 26. So we might be able to argue that this is constant space in this case, especially after we take only the unique values of it. O of n, O of 1, count is +1. That's constant. All right. Feeling relatively good about this. Let's try and put this into here and see if it runs. Oops. Okay, let's have a look at this and see how this does. Oh, the name of it needs to change. Keep that in mind. So passes the test cases. Let's submit it and have a look. Great. This one also runs, and this is more efficient, I believe. Cool. I'm glad that worked out well. And this is one of the reasons why it's always good to double check your approaches. I think it would have been better if I had gotten to this ahead of time. That way we wouldn't have spent our time doing this more brute force approach. So this one becomes O of n plus m time O of m space. I think we could have also applied this concept of a set of the broken letters in approach 1 somehow. We're doing a set for each letter in the words, because as we go for letter, and so here instead of doing for letter in broken letters, we do for letter in word set. Yeah, so this would eventually come down to with modifications. So that's one of the things that we could have still done it with this one right here, but I think the cleanliness of this one without having to split up the string will make for a much better solution. at least in terms of how you show yourself in the interview and your understanding of how to do string manipulation. So what a cool question. I really like this one. I think this is a good one to like focus on. I think it's important to think about different approaches. Maybe there's other ones I haven't thought about either. Feel free to let me know in the comments. Anyway, thanks for watching, and I'll see you guys next time.